Hi everyone and welcome to the demo of Ionir Efficient Multi-Cloud Data Mobility. In this video we will walk through moving a stateful persistent volume using thin teleport between GCP and AWS while minimizing the egress traffic costs. Let's get started. This is the Ionir dashboard with the setup for this demo. We can see that we have Ionir installed on two Kubernetes clusters, one on AWS and one on GCP. The Ionir cluster on GCP shows used capacity of almost 16 GB of data. Clicking on the cluster, we can see that we have a MongoDB workload with 50 GB persistent volume attached to it. The AWS cluster is completely empty. Before we begin teleporting the data, let's go to the GCP networking monitoring dashboard, where we can see the send traffic chart shows low and steady rate. This is where we can see the egress traffic. Egress traffic is charged by the cloud providers as any data leaving the cloud has costs attached to it. Going back to the Ionir UI, we will now teleport the persistent volume from the GCP cluster to AWS and monitor the egress traffic. Click on the volume, choose teleport and start the wizard. We define the destination parameters and set a toggle to thin teleport. This will make sure only requested data reads on the destination cluster running on AWS will travel between the clouds. Click on teleport and teleport has started. The volume is now accessible on the destination cluster in AWS and the PVC is in place to be claimed. On the Ionir dashboard, we can see no data was actually transferred between the clusters and the capacity still shows as 0. Also, egress traffic has not changed on the GCP console. Now let's deploy a MongoDB pod that will mount the volume and see what happens. As we can see, traffic starts to ramp up on one of the nodes, and on the Ionir dashboard, space is starting to be consumed. Now let's execute into the pod and run some queries against the database. As we can see, the database is fully operational and the entire data is presented locally. We can even run a query on it. Going back to the Ionir dashboard, we can see some more data has been copied on demand. This can be verified on the Ionir teleport statistics in Grafana that shows that this query reflected in 1 MB worth of data transfer out of the 12 GB database to satisfy the query. In addition, thin teleported volumes can be cloned multiple times without any impact on the actually used space, thanks to Ionir inline global deduplication. This concludes this demo of Ionir Thin Teleport. We successfully deployed a MongoDB stateful set on AWS Cloud using data teleported from GCP, with on-demand minimum data transfer and maximum application availability. This is the power of Ionir Data Platform. Thank you very much and see you on the next demo.